Thank you, everyone, and welcome. Appreciate you coming, appreciate you making the time for our talk. So we're going to be talking about SquarePhish today. We use QR codes. We've had this tool for a while, but we've added some new functionality to it, so we turned it into SquarePhish 2. So first off, you got a little bit of an intro. I've been in InfoSec a long time. You can tell by the gray hair in my beards. But currently, I'm a senior security researcher on the NG-SIEM team at CrowdStrike. And Cam and I have worked together at multiple places, but he's at CrowdStrike as well. So Cam, you want to come introduce yourself?
Oops. Yeah, I do a lot of offensive tool development. I do kind of purple team exercises at CrowdStrike, but yeah, that was before security. And this is after.
All right, so we thought we'd cover some phishing techniques first before we go into the way SquarePhish works, because SquarePhish is quite different. But back in the day, you could just do credential phishing. You could have a fake web page before MFA. You'd capture a username and password. You trick the user into putting it in. You're good to go. There's also payload phishing. It used to be way easier to get a payload executed and actually get a shell on somebody's machine or a C2 payload. That's getting harder and harder. Even with using advanced payload techniques, macros are becoming harder to run in documents. Just getting people to execute that code is getting harder, and EDR is getting better at stopping it. Spear phishing, that still works. It's still a technique that a lot of people are using to get around some of this, is really focus on a user, maybe throw in some vishing. AI's out there, so there might even be some aspects there you could use. And then OAuth phishing. OAuth phishing's been around for a while. You used to essentially have an OAuth application and get consent granted to it, and then utilize that consent. That's similar to what we're doing, but it's a little bit different, which you'll see here soon. So kind of more modern phishing techniques, things that are working well. The first one is an invisible or reverse proxy. So this is like Evil Jinx or Modlishka. It's where the user is truly authenticating to the site, but there's an evil, or essentially an evil, but invisible or reverse proxy in between, capturing tokens or credentials and post-auth. So that's probably the most popular thing that red teams are using today, I'd say. And then device code phishing is what we're going to talk about today. So it's another way to kind of capture those post-authentication tokens, but we're only going to use Microsoft's legitimate login URLs when we do it. All right, so some key components of OAuth 2.0. So by show of hands, who knows all about OAuth 2.0? All right, so some of you, not many. You don't have to know a lot. The key things are the client ID, which is really a way for the application to identify itself, right? It's how we know what application we're logging into with OAuth. A client secret, which is what you need to kind of present yourself as that application ID. You don't always need a client secret, though. Especially with Microsoft, there are certain applications that have what's called the public flow enabled that you can use with certain authentication flows, such as device code. So you can use first-party apps without having that client secret. So that's important for what we do. There's a resource owner, the client, but what's really important on this page is access and refresh tokens. Most people are probably familiar with those. An access is a very short-lived token that gives you access to the resource. A refresh token is a longer-lived token, and that lets you swap out for an access token. It gives you that much longer, kind of persistent access. All right, so what are legitimate use cases for device code flow, right? We've all used it. You're logging into an app on your TV. You have a remote. You don't want to enter the big, long password you use for everything. So you use device code flow, and you log in from your phone or a computer or somewhere else. It's also used legitimately within companies for like CLI applications. Developers will use it. And then in IoT or medical devices, it'll sometimes be used when you don't have that keyboard to log in. So here's some prior art about device code phishing. So the first public person to talk about device code phishing was Dr. Azure Nestori Semina. He posted about it. Cam and I had already written a tool called Phish in Suits, which was our first iteration of device code phishing. We were focused more on SMS and text-based phishing because there is a 15-minute timeout, which I'll talk more about later. But once that device code process starts, we need the user to log in within 15 minutes. We found a way to work around that. but at that time, that's why we decided to use SMS. We also found it was difficult to get permission to use SMS in legitimate engagements because often organizations don't own their users' phones. So it's a whole consent thing. Janko Wong talked about it at DEF CON 29. Bobby Cook made the technique very popular with token tactics and the art of the device code phish. Black Hills InfoSec did something around dynamic device code phishing. And then just recently, Dennis Neep released a technique called, what he called the novel technique, which is very interesting, and we'll talk about that as well. So why is device code flow good for phishing, right? Users visit legitimate URLs from the auth provider. So in our case, they're actually authenticating to Microsoft URLs. There's not a malicious URL they're authenticating to. We do use a malicious URL in our flow, but as you'll see, it's hidden and it's visited off of the network. Attackers can initiate the process and they will receive the tokens if the target follows through. It bypasses network controls in some unique ways because we're bringing the phone into the process. And then the authentication tokens we receive are post-authentication. So the user does MFA as they're phished, but then after that, it doesn't matter. We have the authentication tokens. So why isn't device code flow good for phishing? There's the 15-minute time window, which I talked about a little bit already. Like I said, with SMS, it was difficult to get permission to actually phish them. And then historically, single sign-on has not been available. All right, so QR codes. Everybody knows what a QR code is. We all know we shouldn't scan them. This page is mainly so that I can have a dancing Rick Roll GIF on the screen. That's the main purpose for it. And if you guys might want to take a photo of this QR code is actually just a short fuzzing string, so it's fun to feed it to applications and see if the application crashes or has an issue afterwards. But they're useful to attackers, right? Because they can hide malicious things like the fuzzing string. They can also hide URLs. They bypass a lot of traditional web security warnings. We'll talk about that more later, but in phishing emails right now, Microsoft does scan the URLs that are embedded in QR codes in some ways. There's ways around it. You could use redirects and redirect Microsoft IPs away from it. You could wait to turn on that SquarePhish server. And you can also use an ASCII QR code, which we can talk about a little bit later. And then when scanned from the phone, you'll see in a screenshot here, the full URL isn't always shown. So if you use a big, long company subdomain that looks like your target, it won't, only the beginning of that will show up when they're scanning it from their phone. I feel like I'm not letting you talk enough, Cam. You got anything you want to say?
No, you're good. Keep going.
All right. All right. So this is the flow, and this is what the flow looks like. The attacker sends the initial QR code or email. So this is the first one. And I talked about that 15-minute window. So this QR code does go back to our malicious SquarePhish server. So it is a malicious URL, but all it is a trigger. This one does not time out. There's no 15-minute window for it because it does go back to our server. What it is it's just only a trigger. It's the first initial email the user will get. It can sit in their inbox as long as they want. The user scans this initial email. You can see what I talked about with the subdomain. You can put whatever long subdomain you want in front of your malicious domain, and it's not necessarily seen. They visit this, and the first thing we do is we immediately redirect them to Microsoft's device code login page. That's Microsoft's legitimate page. That's all the user sees from their phone at that point. In the background, our SquarePhish server triggers that device code flow. So that authentication process is started in the back end now, and our server's working. That server sends a second email to the user with the device code, and again, Microsoft's legitimate URL for them to log into. And this is when that 15-minute window started, but the user's already interacting with the email. They're already part of this process and part of this authentication. This is what the user sees as they authenticate. If they're already logged in, they don't even need to enter a password. If they are not logged in, they'll enter their password and MFA here. And then the only thing a little bit different is the last bit where they're asked if they want to sign into whatever client ID we used. And then if they authenticate, we get their tokens. So this is where we'll talk about tokens and Foki a little bit. So show of hands, does anyone know what Foki is? Oh yeah, we got a couple, good. That's good. So FOCI stands for Family of Client IDs. It's undocumented functionality in Microsoft with their tokens, where you can swap out tokens for other tokens of the apps. So it's kind of how they glued their stuff together and how they make all that work together. But it's also useful for attackers because if we get access to a Teams token, we can swap it out for a OneDrive token and get that user's OneDrive data. So this is all really talking about SquarePhish 1 and the old way you used to do it. And I'll let Cam come over and talk about refresh because he wrote this tool to kind of abuse that FOCI after we get the first token.
Yeah, refresh was just a post-exploitation tool to kind of use the token once you had it. So leveraging the FOCI stuff to be able to swap the token for whatever other token you might need. Being able to access things like SharePoint, OneDrive, anything like that, just anything post-exploitation to kind of go through and dump whatever you need from the Microsoft side. Yeah, that's about it from refresh.
All right, so all that was SquarePhish 1.0. We only had programmatic access via FOCI and via those tokens. We had no path to ESTS auth, so that's a cookie that Microsoft uses in the browser that allows you to sign in across all the applications. I did some research and tried to get to it for a while, never did. We also did not have access to a primary refresh token. So who knows what a primary refresh token is? Show of hands. Cool, quite a bit. All right, so it's mainly just, I think of it as like a refresh token that allows single sign-on to all the apps that really sits on a device for Microsoft. So it's like a awesome refresh token that gets you everywhere, but we didn't have a path to that in SquarePhish 1. And then most of you hopefully know who Dirk-Jan Malema is. He gets his own page here. He did research that showed us how to get that primary refresh token using the authentication broker client ID. So the authentication broker client ID is not a FOCI ID, but we can use it to exchange for a primary refresh token, which gets us single sign-in across devices. After Dirk-Jan did that, me and Sapir Fedorowski wrote a blog about it. Also, Storm 2372, an actual threat actor, Microsoft wrote a blog about it, is using this technique in the wild. So it's real, it's happening out there in environments, and attackers are using it. So it's a good idea to use tools like SquarePhish to test your organizations for this. So SquarePhish 2.0, what did we change, right? Microsoft Authentication Broker Client ID is default because we assume everybody's going to be after that primary refresh token. Automated device registration and primary refresh token creation is all automated. Keywids and Dirk-Jan Malema had their research out, so credits to them for that. Our teammate at the last place, Yo-Yo Chudo, he added an ASCII QR code option, and that helps get by a little bit sneakier. Doesn't always get scanned that way, so it's a way to get your QR code through. It looks a little bit different, but it's just still a scannable QR code that won't necessarily get caught. FOCI and all of our previous pretexts are still available if you prefer those for some reason, want to use a different pretext. We implemented a GUI, thanks to Cam, and we also implemented the novel technique by Dennis Neat, but unfortunately, I got some sad news about that. I'll walk through it quickly. Essentially, the novel technique by Dennis Neep, he found a way where you could submit the device code on behalf of the user. So you didn't have to actually have the user submit that device code. You just gave them essentially what was a URL that the user got redirected to if you stop your authentication process, and it worked out really slick. It was really cool. There was a slight pause when they tried to authenticate, but it was all Microsoft and it was great, except Microsoft patched it, so it's no more. We had to go back to our normal flow. Cam, I'll let you talk about the UI a little bit.
As you guys might have realized by now, Nevada was the brains behind this, and I did a lot of the coding.
Not true.
But yeah, so SquarePhish 1 was like all command line. It was pretty rough around the edges. It just kind of got the job done. We just wanted to have something that was functional, and so there was two original functionality. It was just a server and a way to send emails. That wasn't great. There was just a big configuration file for many different things. It wasn't too intuitive. It wasn't super easy to stand up and kind of run with, so we decided to scrap the entire thing and rebuild it from the ground up. So we built a GUI. One of the main things we wanted to have in here is when we're doing actual campaigns is to have metrics, so being able to see how many emails were sent, QR codes that were scanned, and then the actual credentials. The action section, you can actually just view the raw token itself. So that'll give you the JSON file that it was saved to, and you can just pull out the refresh token as needed. The configuration settings, I mean, there's still a handful to kind of go through, but it's a little bit more straightforward now. The SMTP settings for actually sending the emails, the server settings for where you're hosting the actual server, where the QR code is going to go to, email settings, the subject, body, and everything like that. There's some configurations in there for actually setting up the client ID, scope, and everything like that, depending on if you want to actually swap out and do something different other than the authentication broker. And then the actual send email page, you can specify one or many recipients, specify the phishing email body. There's an option for an actual QR code, which is an inline embedded image, ASCII QR code, which generates the QR code as like HTML, which will get rendered, and then just a raw URL link if you just want to scrap the idea of a QR code. The advanced settings at the bottom was the technique from Dennis Neep, but that's not a thing anymore, so that's just kind of there until we find a better solution. But yeah, and then to kind of go with it, so getting the token from SquarePhish, you get the token for the authentication broker, but to actually get that into a PRT, we wrote a tool called Gimme PRT, which leverages the RoadTX from Dirkjan. It just goes through the process of registering a fake device, creating the token associated with that device, and then doing a little bit of cleanup to deregister the device. But this is just a one-stop shop to kind of give you that PRT from the actual token. It was just a nice pairing of it, and that's why it's kind of a one-off tool, because we rewrote the entire tool in Go, and this is still in Python because it's still leveraging Dirkjan's library. But
yeah, this is just an example of an AI-generated template, that you might use for a pretext, what it could look like for that initial email. All right, and we're at tool demo, which is awesome because that's a great timing. So, way in the back is my kid, Mace. I just got to give him some credit here. He redacted this video for me, so we're not showing any actual tokens. That's why we're not doing a live demo. It's definitely because we're not chicken. All right, so on the right, you have the attacker, and on the left, you have the victim. So kind of, put that in your head. On the right, you can see SquarePhish. You do need an SMTP server for this one because we're using the automatic emails in there. I use Namecheap for mine, it's like 13 bucks a year, so it's super cheap. But here you can see the emails, HTML. That's for the second email the server sends. These are kind of the server-side settings. You can see a preview. We have an open preview button, so you can see what that email will look like when it's sent to the user. You can see the client ID we're using there in our pretext, which is going to be authentication broker in most cases. And then this is the send email page. This is where the initial one goes out. You can do a full list. We keep track of the users via a get parameter in the actual malicious URL. So that's another reason we have automatic sending of URLs, because we can track which user is authenticated. You can see the preview there. That's where the QR code will go when we send it, and then we'll send the email. You'll see it show up in the user's inbox on the left-hand side. And again, this is that initial email that can sit in their inbox for as long as it wants. The user's viewing it, and then off screen we're scanning that email. So we're firing that trigger, essentially. And as that email's scanned and that's triggered, you can see right away that that user gets a second email asking them to authenticate with the device code flow. They go right to Microsoft's actual web page and use that device code in it. And you can see here, they're already logged in. So again, this is all post MFA. If they need to enter MFA, they will there, but after that, our tokens have it. And then they're signed in. You'll see on the right, a new token will appear after it refreshes here, and we'll have a new token from that user. And now we're going to go ahead and view it, because we need to turn that access token or that refresh token into a primary refresh token, because that's what gives us the single sign-in. So we're going to use the gimme PRT script. Again, that's a Python script because we're relying on Dirkjan's RoadTX library in order to help turn that into a PRT. And we're going to feed it the refresh token. If I can paste it. All right, and there's that nice redaction I said we did. so you guys can't steal my tokens. And then this goes through and it actually registers a fake device with Microsoft. That's how we get that primary refresh token. We have a fake device registered. We put that primary refresh token on the device, and we have it as a text file. Now we're going to use another one of Dirkjan's tools in order to authenticate using that PRT. So we're going to use a browser auth to authenticate using essentially Selenium and Firefox and authenticate using that user's PRT. You're going to see a Firefox browser pop up here with a red banner. That's the attacker authenticating as the victim. And I'll drag that over to the attacker side of things since that's where we are. And you'll see when I click sign in, the attacker is automatically signed in as the victim, and we have access to all their applications. So that's most of the demo. We have a demo in here of the Dennis Neat technique. Won't show it because it doesn't really matter. It just looks a lot like that, except they don't have to enter the device code flow. There isn't two emails, and there's a bit of a pause. But you might be wondering about detection and prevention strategies. So I think I have 3.5 minutes, so I'll cook through these. The best thing to do really is look for that authentication broker client ID with the device code authentication protocol. So that should be unusual for most users in most environments. There may be, there might be a legit use of this, but it should be only a small subset of users, so you should be able to allow list this. That's the approach I take. Create a detection rule, allow list the users that are actually using this, if any actually are. Even better, look for just device code authentication. In most corporate environments, again, this should not really be happening that often. Maybe some developers are doing some weird things, whatever. Create an allow list, only allow the users that are actually using device code authentication to use it. Conditional access policies. So obviously blocking device code flow, right? I said if it's not normally happening in corporate environments, let's just block it and not have it there. That can be done via CAP, I believe. I also have heard that Microsoft's implementing like just a switch for it. I haven't seen it myself, but supposedly it's coming. The rest of these are pretty much just good security recommendations, limiting resources to trusted IPs, VPNs. You guys know all that stuff, so I won't go through it. There's a link if anybody wants to dive in a little bit more. But that's really it. Thank you very much for coming to the talk.